Hello everyone, welcome to Olsen Cafe. Now, some of you have requested for me to produce video lessons on sets and its notation. So here it is. Now, do you know that every time when you go grocery shopping, you are actually using a mathematical concept called set? In fact, what you see on the screen right now can also be classified in sets. So you can see that we have pencils, we have the set notation, we have the paper clips. So all these are able to classify under sets. So here is another example of sets which is visually represented by a Venn diagram. Are you able to name some day-to-day examples of sets? Now, whether you are picking up fruits, organizing your favorite movies, or even planning your daily schedule, you are subconsciously working with sets. But what exactly are sets, and why are they so important in mathematics and in our daily lives? So many students ever ask me, man, why is set so important? Why do we need to learn set? Yeah, because it seems that set has nothing to do with what we are doing, in our daily life. But the actual fact is that sets form the very foundation of mathematics. It is very extensively used in statistics, especially in probability. So many of we can think of sets as the building blocks of maths. Yeah, without them, we are not able to have the tools to categorize, to analyze, and to understand complex relationship between different mathematical concepts. It is something whereby you may not appreciate right now, but as you move on to higher institution, right, you will get to see and get to appreciate set a little bit more. So before we dive into the lessons on set, let's address some of the common confusion that many students face when they first start learning about set. So what is the most difficult part of set theory? All right, number one, it is a terminology. All right, and then the other one is the notation, which we are going to cover in this particular lesson. So let's get started. We will begin with some of the common terms that we will come across in set. So the first one, we cover the types of set. So over here, the example that I show you is called a finite set. So in this case, I have a set A. So this set A represents the set of prime numbers that are less than 17. So do take note when we talk about prime numbers, you notice 1 is not in here because 1 is not a prime number. Yeah. So over here in this case, all right, you notice that there are 6 numbers in this set A. So therefore, I say that there are total 6 elements. So N stands for number. So the number of elements in set A, there are 6. Yeah. So the other symbol that you need to be very familiar with will be this symbol that looks like a letter E. So this simply reads as 2 belongs to set A. That means the element 2, it is actually an element of set A because 2 is an element here. Yeah. So the opposite is which is this. So which means if you look at it here, right, is 4 a prime number? No, 4 is not a prime number. So therefore, in this case, I say that 4 is not an element of this set A. So with a slash in, this stands for not an element. So over here, you see another representation of a set. So we call it a set builder notation. So this is another representation. So what you see here is you have set A. So over here, you notice that is we have this colon. So this stands for X is such that, yeah, the set builder notation. Yeah, so that means X is such that it is a prime number and X is less than 17. So this is another way to represent whereby this variable X that we use it here is dummy. So we can actually use any other letters. Yeah. So this is another common representation that you get to see in set notation. Okay, now we move on to the next type of sets, which is called the infinite set. Now, infinite set is opposite to finite set, as we have seen earlier. So finite set means we can count, right? The earlier example, there are 6 elements here. But now we are talking about the infinite set. So basically, there's unlimited number of elements. So in this example, we see this set builder notation. So what we have here is we have a set B. All right, set B is such that is a letter X in such that X belongs to, all right, what is Z? This Z actually stands for all the integers. Yeah, so X belongs to all integers and is such that X must be greater or equals to 1. So therefore, if we understand what this set builder notation means, so if I'm going to list all the elements, it simply means 1, 2, 3, 4 is all integers. And you notice there is no end to it. Yeah, so therefore, all right, the numbers here, there is no ending. All right, so it cannot be counted. So the list will go on and on and on. So in this case, right, we say that this is a infinite set. So therefore, well, what is the number of elements in this set B? It is undefined. There are so many. Yeah. Okay, next we move on to Venn diagrams. So Venn diagrams is very commonly used under set theory. Yeah. So in a Venn diagram, it is very easy for us to see the relationship between sets. Yeah, because sometimes by seeing numbers itself, it is not very clear. So Venn diagram is actually useful. Yeah, so when we talk about Venn diagram, right, we will come across this particular symbol, right? This symbol is being pronounced as epsilon, right? So there is a universal set. So how does it look like? So it simply look like this. So in this case, I see a rectangle. So this rectangle usually represent the universal set, whereby we label as epsilon, and usually the set A is inside. We either use a circles or we use oval shape to represent the different types of set. So I will cover it a little bit more detail as we go along. So over here, I am going to use Venn diagrams to illustrate the different types of set relation. Yeah. So the very first one over here, which is the common one, which is what we see is here. So in this case, you will notice that, all right, there is a smaller circle, all right, inside a bigger circle. So in this case, I use a Venn diagram to illustrate that, all right, the smaller circle is actually the subset of a bigger circle. And in fact, in this case, the two circles are the subset of the universal set, right, which is epsilon. You see the notation there. So that is the very first one that you see, right, that explain to you what is the meaning of subsets. Now then there is another one whereby you may have seen this before. So we have two circles. So when we have two circles that is overlapping one another, so which means we say that these two sets, there are some common element between them. Yeah. Now then the next type that you might see, which is like this. So in a case whereby when you have two circles, or rather two sets, there is no intersecting point. So in this case, yeah, we call it a disjoint set. So basically these two sets are disjoint. And in such case, right, the representation, that means there is no intersection. So in such case, right, usually, right, you'll come across what we call the empty sets or the null set. So empty sets or the null set, that means there is no element within the set itself. So the intersection between these two sets is basically zero, right? There's nothing, there's no element inside there. So these are some of the common relationship, all right, that you will see between sets. Okay, so over here, I am going to go a little bit deeper, all right, into subset and proper subset, which is what most students find it very, very confusing. Yeah, so let's look at this example. Now, so over here, you can see that I have a universal set, which is denoted by epsilon. So this stands for the numbers between 5 to 10 inclusive. Then I have set P as odd numbers and set Q as the numbers not divisible by 2 and R as prime numbers. Now, this is the typical question that you get to see. Now, so by just looking at these words, it's not going to help us. So usually what we are going to do is we are going to list out all the numbers before we can see the relationship. So by listing all the elements, all right, in the respective set, this is what we have. So you can see that the universal set, we have 5, 6, 7, 8, 9, 10. All right, we will end here. So what is the meaning of universal set? So that means subsequently for my set P, Q, and R, right, we are going to list all the elements, all the odd numbers given in this universal set. Anything that is not in the universal set, we do not include them. So over here, the universal set, the elements are from 5 to 10. So therefore, between 5 to 10, what are the odd numbers? Which is we have 5, we have 7, and we have 9. So we list it up, right? The P. Then similarly for Q, we have 5, 7, and 9 because it's numbers not divisible by 2. So I exclude 6 and 8 and 10 because 6, 8, and 10, these are divisible by 2. So by listing it down, I have 5, 7, and 9. So likewise for prime numbers, so within this universal set, so which are the prime numbers, right? Which is 5 and 7. So this is what we do, all right, at the start. So we list all the elements. Now we are going to represent these elements using a Venn diagram. Then you get to see the relationship. So let's see what happened between set P and Q. So I will illustrate point R later on. So you can see universal set is usually represented by a rectangle. So I have two sets, set P and set Q. So you'll notice that in this case, set P and Q. So for these two sets, right, set P and Q, you notice that Q can be represented as a smaller set of P. So in this case, right, I say that Q is a subset of P. So when Q is a subset of P, what you notice is that there is a extra line, all right, below the symbol. So this extra line, you can take it as like an equal. So that means there is a possibility for set Q to be equal set as set P. So that's why we call it this as a subset. All right. So subset means there is a chance for them to be equal set. Now, so let's take a look at another relationship. So in this case, I'm going to look at set P and set R. So by putting all the elements in here, right? So you notice that for set R, I have 5 and 7. And how about set P? Set P, I have 5, 7, and 9. So where is 9? So where should I place the number 9? Can I place the number 9 inside set R? Obviously not, right? Because 9 is not an element of R. So where should I place 9 then? So in this case, all right, you notice that I will place the element 9 outside of R, but inside of P. So this is how the sets are being represented in terms of Venn diagram. So if you take a good look at this, right, so you notice that for this set R, it is actually a smaller set than set P. So in this case, can set R be the same as set P? Right? In other words, is set R equal to set P? Answer is not. Yeah. So therefore, over here, what we say is that set R is a proper subset of P. Yeah. So I hope with this diagram, it helps you to understand the difference between a subset and a proper subset. So a subset simply means that it's a possibility for the two sets to be equal. Whereas when we talk about a proper subset, there is no way for it to be equal. So in other words, R must be a smaller set than set P. So this is how we illustrate the difference between proper subset and subset. Hopefully with this diagram, you can understand a little bit better. All right, over here, I'm going to show you some of the common notation that you get to see in the different types of number set. Yeah, so we can see we have the natural numbers. So natural numbers are just like all the positive numbers, except that 0 is not included. Yeah, so we have whole numbers. The other one that we commonly see is integers. So make sure you know the difference between integers and natural numbers. So you notice that for integers, we include the negative values, whereas for natural number, it's all positive. Yeah, so the next one that is very commonly used, which is rational number and irrational number. Right? Rational number, that means all the numbers that it can be written it as fractions. So they are called the rational numbers. So irrational numbers, are you able to quote me some example of irrational numbers? The common one would be like pi, third, all these are examples of irrational numbers. Now, R stands for real numbers. So basically, real number is any kind of numbers that you come across. Yeah, so it's basically called real numbers. So sometimes, especially for students learning A math, you'll come across this term very, very often. Yeah, so the last two, whereby we talk about the imaginary numbers and the complex numbers, these are the two that you will actually come across these terms more often when you move on to higher institution, which I am not going to cover over it right now. Right, so over here, what you see is I'm using Venn diagram to show you the relationship, which is if you early on, if you just look at the set notation, right, you are quite difficult for you to see how they are related. But the moment if I use a Venn diagram to illustrate, you get to see, right, the relationships between all the number sets. So you can see that natural numbers, it is a proper subset of integers, and then where integer is actually a proper subset of rational number, and then if all the real number, these are irrational numbers, and then and all these are the smaller sets of real numbers. So you get to see how useful Venn diagram is, right, to illustrate the different relationship between the number sets. Right, we have covered quite a number of terms and notations by now. So let's do a quick recap before we forget, yeah? So let's go through them and see if you are able to recall. So the first one, the first notation that's look like a letter E. So this simply means an element, yeah? So if I say that is 2 is an element of set A, that means 2 belongs to set A. Then the next one with the slash in between, so this is simply means not an element, yeah? So which I covered earlier on. Then the next letter that we have, not letter, the next notation that we see here, this is pronounced as epsilon. So this simply refers to the universal set. As long as the universal set is given, so all the other sets have to be with reference to this universal set. Now, how about the next two? Are you able to differentiate between them? Yeah. So this one here that is without the equal sign or extra line beneath. So this stands for a proper subset. Yeah, proper subset. If A is the proper subset of B, means A is a smaller set of B. Yeah, so the other one, all right, it will be a subset. Okay, so subset it simply means that there is a possibility between the two sets to be equal. So that's why there is the extra line below. Now the last one that you will come across quite often, all right, this is simply refer to the empty set, or all right, you can call it the null set. Now, so these are some of the common notation that you will actually come across. Right, so today we have covered some sets and everyday life. I've covered some of the basic concepts and the terminology and also its notation. So what I'm going to cover next, it will be the shading of Venn diagram. So today I just use Venn diagram to illustrate to you, right, the different types of relationships. Yeah, so in my next video, I'm going to cover the term called intersection and the union of sets, and also complement of sets. So all these we are going to use Venn diagrams to illustrate to you their relationships. So hopefully you find this useful. So if you find these lessons useful, do drop a comment below and share your experience. All right. So if there is any specific topics that you would like me to cover in the future video, so do let me know. All right. I'm always looking for ideas and how I can help you right over here. So do remember, if you like my lessons, do remember to subscribe or even like the video. So I will see you next. Okay, bye bye. Thank you for watching.